Good day once again, everybody. How are we doing today? My name is Michael Boyo, founder of MBKonsult. I'm super excited to have everyone here. So today we have, another fantastic topic to run through. It's introduction to data analytics. And I have my very good friend here, friend and brother, that has graciously, made himself available to share with us his expertise. So, what I want to quickly say is data analysis and business intelligence analytics the right career for you? Like I said, Lade is a very good friend, right? Whom I met recently, our path crossed, in a very interesting fashion. And it just looked like as if we were cut from the same cloth, right? Very, very ambitious, intelligent, smart, and he knows his craft, right? For me, when I identify someone that knows his or her craft, that's the kind of people I want around me, right? He's a data engineer with the City of Edmonton here in Alberta. And like I said, this is not somebody that's just going to come and tell you stuff, but he's coming to share from his own, professional experience.
Thank you again for attending this session. I'm facilitating. My name is Lade Shelle, like Mr. Michael introduced me. I'm a data engineer at the City of Edmonton, and I hope you enjoy this time that I spend with you. So we can move to the next slide. So this is our course outline for today. We can't talk about data analytics without knowing what data is. And then we'll also find out what data analytics actually is, what the steps in the data analytic process is, and then we'll have some time for questions. So, what is data? Data refers to raw facts and figures that are collected and stored. So a good example of what data would be is how many people today are in this session? From what I see is about 20. Oh, Mr. Michael, you were going on?
No, go ahead. No, go ahead.
Yeah, from what I see, it's 20 people. So that is a figure that we have collected. And then if I put it somewhere, so if I write it down, then it's stored. That becomes data. Another definition for data is it's a collection of observations or measurements represented as text, numbers, or multimedia. So again, like in the first definition, it means that you are taking down something, an observation. If I go outside and I say, what's the temperature outside? At this very moment, it's 12:18 where I am, and I take down the temperature and I say it's 12 degrees. That's data. Now, I've written it somewhere. If I keep it in my pocket, it's stored. I can retrieve it later for whatever use that it will be called upon for. So those are examples of data. So let me read that definition again. It's a collection of observations or measurements represented as text, numbers, or multimedia. Now, we are recording this session. If we ask in the future and we say, how many people attended this session, it would always read as 20 people in a video. That's data. So I'm just giving you some examples of data there. Data exists in different forms. So the different forms of data includes numbers. You can take field notes like the scientists do. So they go, if you are in science, you record your observations in the lab. If you're outside, you record your observations. Those are examples of data. Videos, like I said, we're recording this session. It's an example of data. Audio, pictures, documents, etc. Now, let me give you more commonly familiar or data that you're familiar with in your professional lives. It's a company's sales figures for the quarter. So we ask, how much did we sell this quarter compared with last quarter? That's data that is being used practically in the company. Another example is temperature readings for a city taken at intervals. or a set of survey responses. Some people go out and they say, let's go and collect data on the sort of people that might be our customers. Those people would be, and sorry, you can stop me at any point in this lecture to ask questions, just putting that. So if you
Yeah,
have
that's
any
what I wanted to
questions,
ask. So people can
yeah,
so raise up your hands and ask at any. Yeah, I think that's good so that it becomes interactive, and you can
yeah.
actually ask the audience question as well, right?
All right.
Yeah.
Yeah, yeah, for sure. And please don't feel like you're under any burden to answer. If there's nobody that wants to answer, if you're not comfortable, that's
I can
fine.
call names. Don't worry.
Yeah, you can call names. All right. So yes, those are typical examples of data being collected and being stored and being used. Now, we can classify data in two ways. We can say it's quantitative data, or we can say it's qualitative data. Now, quantitative data is data that can be expressed in numerical form. So we'll look at those types of data as measures. Again, count is an example of a measure. Speed is an example of a measure. So anything that has number attached to it is quantitative data. We can say the inflation rate is a type of quantitative data. As far as there's a number and it's number that can be manipulated and calculated, or it can be transformed, whatever it can do, and it's numerical, that's quantitative data. Now, qualitative data is data that is representing information and concepts. So we can put it as categorical data. That would be like dimensions, really. So we say types of human beings. We say they are boys or they are girls, they are men or they are women, they are old or they are young. It's sort of like a label. And then you have different categories under it. You can say teenagers, you can say adolescents, you can say seniors, you can say young adults, you can say adults. Those types of data will be classified as qualitative because they represent information. So can anybody here give me another example of what might be quantitative data and what might be qualitative data? Anybody else?
Let's not feel shy to speak. Oh.
Me too, I'm very shy, so I can understand. I can
No, no, they
understand.
can't be. Me, I'm not shy. So me, I can tell you that right up front. So, except you want me to start calling names. So, who is going to bail the cat now? Other examples of quantitative and qualitative data. Okay. So, Dami, tell us. You are the BA. How do we put it? Personified, right? So, what? At
I'm
least I
not
got
yet
you
in
to talk,
jail.
right?
I'm still on the journey.
So, okay.
Yeah, so
So, give us example, right?
quantitative data, it could be anything, it could be anything at all that we can count. Just like when we're doing last project, we were able to count the number of accounts, that were coming into our org.
Yep.
So,
Mhm.
you know, number of leads, number of opportunities that we brought into our org, and then we did some analysis to know which one has the highest, the highest income, which one has the lowest income, and
Mhm.
all that. So those kind of examples can be quantitative.
Correct. Correct. So can you also give me qualitative data, or is there anybody else? I saw someone's hand was up. Israel's hands were up. Israel,
Yeah,
please.
Israel, please go ahead.
Okay, so I'm going to leverage on what the last speaker has said. So qualitative data basically is data you collect that you cannot measure, right? Quantitative has to do with numbers, right? So specific absolute numbers that you can measure. But qualitative, they are more like questions, right? So if you're going to get, let's say, for example, you want to know so I'm a public health person, so I'll use public health examples. So like the number of immunized children, right? You want to do maybe like a focus group discussion or maybe a key informant interview to get information. So it's what they tell you verbally, right, about it, that you document down, and you can somehow weigh it or just give it indices along the lines that you can use to generate information.
Mhm. Very correct, sir. Very, very correct. So I like what Israel said. There was something he mentioned when he was giving his description of quantitative data. He said measures, things that you can measure. So once you can put it in a numerical form, so speed, acceleration, pressure, anything that you can measure, number of clicks, number of impressions, the rate of participation in a survey, those are numbers. And so those are quantitative data. Now, if you're looking at qualitative data, it is what you are now going to use to represent those numbers. So you now say rate of participation, but they are provinces. So rate of participation in what provinces? In Alberta, in Ontario, in Nova Scotia. We put it in states. Lagos State, in Ogun State, that would be example of qualitative data, because it's not numerical, but it does represent information, or it represents a concept that you can count. So you can say how many states are there in Nigeria, for instance, and then you say there are 36 states, including FCT, right? So that's just the basic, exactly. So Mr. Michael has put it very aptly there. You have quantitative data as measures, and you have qualitative data as dimensions. So we'll get to that in the next session when we're looking at visualization as well. So let's move to the next slide, please. So now, properly, let's get into what is data analytics. Data analytics is the process of analyzing raw data to extract useful insights. These insights can be used to drive smart decision making. So I'm going to pause there and then I'm going to explain. So basically, now you have all of this data, but what are you doing with this data? What is it to you? So you can have all of this data and make no decisions out of it. You can make no meaningful insights out of it. You can just hold it. For instance, like I always use this class, we have 21 people now in this class. And then we can look at previous classes and say, oh, how many people were in the last session? How many people were? So thank you again. The session before that. How many people have been in the session for? I'm facilitating. My name is Lade Shelle. For last year, Mr. Michael introduced me. I'm a data engineer at the City of Edmonton, out of this, and I hope you enjoy this time that I spend with you. A physical. So we can move to the next slide. Session. Let's know how many people are coming from what location. So this is our course outline for today. From that number, we can now determine talk about data analytics without knowing what data is. So if and then most of the people that attend the session find out what data analytics actually is. It makes sense. What the steps in the data analytics process is, and then Nigeria. It will make sense if one person is in Russia, and then we have this entire group. So, and then we say, okay, well, data? We're going to choose Russia as the host. Data refers to raw facts and figures, or an next in-person event stored. So an example, a good example of what data would be is how many people today you take all of the information or all of the data from what I see, and then you analyze. Mr. Michael, you were going on, and then you try to extract meaningful. Yeah, from what I see, it's 20 people insights that will make you that is better decisions. A figure that we have collected. The next bullet point was analyzing somewhere. Interpreting data, I write it down, help you identify trends and patterns. That becomes and provide solutions to problems. Another definition for data is, let's look at it's a collection of observations or measurements, for instance, represented as text, numbers, or let's use Netflix. So now again, Netflix, like in the first definition, it means that you are taking down something, an observation. If I go outside and I say, what's the temperature outside? Now Netflix is we have it's 100 million subscribers where I am. Problem now I take down the temperature and I say it's that 100 million degrees while we're acquiring new subscribers. Data. We know that
Now,
there's a market.
I've written it
The
somewhere.
market is, let's say,
If I keep it in my pocket,
300
it's
million people
stored.
that can afford subscriptions.
I can retrieve it,
and we have
later
100 million.
for
How do
whatever
we be
use
the
that
dominant
it will be
player in
called
this
upon for.
industry?
So
With
those
live
are
streaming video, right?
those are examples of data.
And they look at their data.
Let
and
me
they
read
say,
that definition again. It's a
well,
collection of
there's
observations
only one way
or
to keep
measurements
subscriptions, and
represented
that's
as
to
text,
keep people
numbers, or multimedia.
watching our content.
Now, we are recording this
Right?
session.
Now, so they analyze data and see what
If
is
we
the trend
ask
in what
in
people
the
are
future
watching.
and we say how many people attended this session, it will
How many
always
hours are they
read
spending on
as
this
20 people
content?
in a video.
How many hours are they spending on that
That's
content?
data. So I'm just giving you
What are
some
they sharing
examples
on
of this.
social media also about our content? How is our marketing campaign of one product different from the other product? I mean, they keep all of that information, and all of that information is how they make better decisions in even the sort of content that they create. So they would say, now let's make movies of this kind because everybody is watching this kind of movies, or let's make movies of that kind, or let's acquire movies of this kind versus that kind of information, right? So that's a practical example of where a company is analyzing and interpreting data, and they're using it to solve a current business problem. Companies and businesses use analytics to make faster and smarter business decisions to, one, reduce the overall business costs, and two, develop new and innovative business solutions. So the most important things for most businesses, and this is why data is a big economy. It's not just an industry, it's an economy, because there's industry for acquiring data, there's industry for distributing data, there's an industry for analyzing data. It's an economy of its own. It's like the oil economy. Now, the main thing about any business in any economy, the first thing is to reduce your overall business cost. So when you acquire data, you look at where are we wasting resources. An example, let's say it's a restaurant and they buy certain ingredients every month. Now, they realize that some of those ingredients, they don't even use acquiring exactly. Some of those industry, some of the restaurant doesn't use some of those ingredients, right? They use 50% of it every month, but they keep buying it again in this quantity every month. Now, one quick way to save money for that restaurant is to take data about all of the ingredients that they are using. What is the usage at every point? So in January, it might be different. People might prefer warm foods when it's cold. So there's Hamatan, there's winter, you're looking at December, you're looking at January. So pepper soup is selling more than jollof rice, for instance. Now you look at that every month over different years, and then you are able to adequately predict which ingredients you need to stock up on to save money or reduce costs. That's just a typical example from a restaurant's point of view. Can anybody else in the audience give me another example of where you can save money from looking at your data or reduce costs? Dami, please go ahead.
So if we have some stores in Canada now, they are looking at the kind of clothes that they stock in their stores. So now we are leaving winter coming into spring. Those stores will not stock winter wears. They will stock jackets.
Exactly.
Winter is going already, right? By the time we enter summer now, they'll be stocking light wears, t-shirts, bumper shorts, and all that, because now we are right. So it is the type and the amount of clothes that different customers buy per time that will determine the amount of clothes that they will stock. So it is analyzing, getting those data, distributing it, and analyzing those data that will allow them to take this decision about the kind of clothes that they will stock per time.
Thank you very much, Dami. That was a perfect example. Now, even to add to that is that even up to colors, right? If you are looking at spring colors, they're the colors that match the leaves of the trees outside and just the general ambience of the environment around spring compared to when it's summer and compared to. So if you are, for instance, a clothing store, you want to stock up on colors that are more vibrant around spring and summer, and then stock up on colors that are dull and beige-like around the cold months. So that's a perfect example. Thank you so much, Tammy. So we can move to the next slide. Yeah, so in continuation of the last slide, organizations use analytics to predict sales and customer behavior. They use it to prevent fraud. They use it to measure marketing campaign performances, improve customer acquisition and retention, and enhance financial performance. I mean, this is just corporate speak. It's a lot of grammar for saying, basically, if you have data as a company, then you can be more successful and you can be more prosperous. Basically, an example, again, is like to predict sales. Now you have your sales numbers, and then you put a line regression to predict what the next year would look like. So an example, let's say year on year, your sales has always increased by 10%, or roughly around 10%. The average is around 10%. It means that next year you can forecast how much you would get in sales, right? And that's a great thing to have as a business because it allows you to plan better with your resources. So you know how many new staff members you need to get, you know how many new outlets you need to open, that sort of thing, if you're like into retail. Customer behavior as well. Like we use the example of Netflix. Netflix is always monitoring how much time you spend on each content, where you pause, where you slept. An example of where they measure where you slept is they will ask you the question, are you still there? Are you still watching this content? At this point, they know that you stopped watching it. So they are keeping all of this data meticulously, is also to understand the customer behavior. That way they can serve us better. Prevent fraud. Banks use data to do fraud detection and fraud prevention. So an example would be a bank has an algorithm. They can determine every time when you use your card if this might be a fraudulent transaction or not. Let's say you are in Russia, you are home-based, you reside in Russia, you've been using your card in Russia, you buy it, you pay for things, grocery in Russia, and then one random day, somebody is using your card online in Australia. They can predict that that is likely fraud. Or you've used your card twice in one physical location, and then all of a sudden, you are at a third physical location that is thousands of miles away. They can always predict that that's fraud. So those are the sort of things that an organization that is using analytics can measure. Does anybody have any other examples that we can discuss? Let me leave it to the floor. Let's use an example for improving customer acquisition and retention. I'll give it a minute. All right, I'll just go straight ahead at so measure.
Sorry, Lade, I was looking for the unmute button. So
Yeah.
I like the example of Netflix that you said the other time. I was on a webinar where one of the analytics team leads at Google, who is responsible for customer retention on YouTube Premium, was saying that what they have now is that only about 3% of YouTube users, of those that watch YouTube, actually sign up for the premium subscription. That means pay. And one of our team's responsibility is retention. And I know she said a lot of things, but so I'm just bringing that out as in to buttress what you are saying on the Netflix that, and that's why somebody like me, I have Netflix and I necessarily don't pay for Prime, for
Mm-hmm.
example, just because I'm like, it's just same of same. And there are so many other video streaming platforms, right? And I'm sure the competition will be steep, even though most of us seems to be very familiar with Netflix, right? And so I'm sure that they would need to be doing something behind the scenes, measuring a lot of analytics, like you were saying. And I would expect that they would need to see what the other side is doing that they are not
Mm-hmm.
doing, right? They need to be
Mm-hmm.
capturing even analysis from the competition to
Exactly.
now to inform what they will be doing in order to have a larger market share of that particular industry.
Thank you so much. Those were very, very valid points,
Thank
especially
you.
using the example from Netflix on customer acquisition and customer retention. I see Julie's hand is up. Julie, do you want to go ahead, please?
Oh, okay. Hi. I've worked with the Paramount, still it's there streaming up. And
Mm-hmm.
one of the strategies on retentions was mainly running campaigns and measuring cancellations during certain periods. Like
Mm.
mainly in the summer, the cancellations were high because people were outdoors, and
Mm-hmm.
winters, they were quite low because people are indoors. So they run campaigns accordingly to that. With that data, you can like minimize on the like whenever there's a cancellation in summer. I think this is the best time sometimes to subscribe to most of the streaming apps. If you want to cancel, they can give you like 2 3 months free or something. So
Mm.
it's just in relations with the seasons and like what people are literally streaming within that time. Pretty much, I think that's it.
Thank you so much. And that is a very, very, very valid example of using data for your marketing campaign. So, like she said, they noticed that people basically cancel their subscriptions around the warm months because everybody's outside. Now, they're not watching a lot of TV. They can rely on YouTube for some of their content, which is free. So they have alternatives around that point, and that informs the decisions that they make around their marketing campaign. Very beautiful example. Thank you, Julie. Now, okay, people are still joining. Sorry, that was it came up as a pop-up, and I wasn't paying attention. So, improve customer acquisition and retention. I mean, just like the examples that we've just shared. Customer acquisition. Now, if you have general data around your industry, around your market, around the demographics that are buying your products, then you are able to improve the strategies that you put around customer acquisition and also customer retention. So, like Julie said, now they were offering 3 months when somebody wants to cancel their subscription. That's understanding customer behavior, looking at the data to say when are these people going to cancel, and let's keep them all the while. We'll spend this little money to keep them all the while during the 1 month so that they can continue paying once they have nothing else to do but to stay inside. So that was a great example. Thank you so much. I'll go to the next point. This analytics benefits every business decision maker. I think there's a typo here. I forgot to correct it. We can ignore that typo. But basically, what it was saying was if we have all of this abundance of data, ignoring it means that we are risking some missed opportunities and we've overlooked certain problems around our business operations. Now, leveraging analytics, we can now gain competitive advantages and mitigate potential issues effectively. Again, a lot of corporate blah, 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 a lot of big words being used there. But what this speaks to is you have two businesses, for instance, they have similar customer bases. Let's say it's a company that caters to teenage fashion, for instance, and most of their customers, well, maybe it's not teenage fashion, they cater to young people that have money, for instance, and then they look into the data And then they figure out that most of their customers are actually teenagers and people that are much younger. That's where most of their money comes from. And then they are trying to choose a site for their store in a city, right? And compared to another business that isn't looking at the data, or they're not looking at the data appropriately, and they're saying, let's just site our stores somewhere where there's a large distribution of people. So let's go and site several stores in suburbs where it's closer to that demographic. And now there's another company, the earlier company, what they've done is they've looked at the demographic and seen that their customers are between the ages of, say, 18 to about 28. And those people mostly stay around a downtown more, or they are more downtown in location or in where they reside as compared to the suburbs. Now that team goes ahead and then they create stores downtown and they put their marketing and their sales efforts in that location compared to the team that wasn't looking at the demographic of people that were paying for their products. And we're just looking at the demographics in general and looking for numbers. Yes, please go ahead, Danny.
Just to like a rider to the point that you just stated now. I remember back home in Nigeria when I used to work for a company, we were trying to make a decision on our expansion efforts. So the company was kind of, had one or two outlets, and they were trying to like take a decision on the region that they want to expand more into. So that decision was a very pivotal decision that will affect the success, or otherwise of the company. So what did they do? They went back to the data, right? And they looked at which region had the highest sales. And if they didn't get, if they didn't keep the records of the region that had the highest sales, so this company is an animal health company, and they looked at okay, in Lagos State, how many clients brings in their dogs for treatments over a period of 2 years, and they were able to analyze those data as compared to the number of clients that were able to bring in their dogs, over a period of 2 years in local states, and found out that of course Lagos State had more. So because of that, to take the decision to concentrate their efforts in expanding more outlets in Lagos State as compared to Ogun State, and because of the availability of such data, they were able to take a very good decision, and the company is still running to today.
That is a great example. Thank you so much, Danny. That buttresses the point that we're trying to make, that if you have sufficient data and you analyze it appropriately or efficiently, then you'll be able to make very good business decisions that will lead to profits. And let's even use examples from like the city where I work. I work for the city, and some of the things that we track is fleet management. We track the fleets that go for waste management. We track the fleets that are used for transit. We want to know where they are stopping. And there are sensors on all of these vehicles. So those sensors tell us where a vehicle stopped, where a vehicle was not driving according to road practices. It just measures like a position on the road, the deviation from the lines on the road, such things, right? So now what the city would do is they'll take all of this data and then they're able to determine which of the drivers are taking too long a coffee break or too long a smoke break, and how that is impacting like the general traffic in the city. I mean, those are just general examples of using data to make business decisions. So that's a resource thing where they send it to human resources and say, this is the data of all of your drivers. This is where they are stopping. These are the ones that are stopping here. This is the most common places where they are stopping. These are the periods in the month where there's, for instance, it snows, and then it becomes difficult for the drivers to get to where they are. And so that's why there's a delay. So you expect all of these delays ahead of time. You can predict how you manage other people that are transit riders, or other people that are expecting their waste collections. Does that make sense?
Yes, it
Great,
does.
great, great, great. Let's move to the next slide. Now, we can't talk about data analytics again without talking about the various types of data analytics. And these are the types of data analytics based on what we are trying to achieve with analytics. So we'll start with descriptive analytics. That's one type of this of analytics. This describes what has happened over a given period of time. We can say this is like a trend analysis, right? So as a company, I want to know what our profit has been saying over a couple of years, every month and every quarter. So I look at the data, we look at how much we've sold, how much profits we've made. We've taken all of our operating expenses, all of our discounts, whatever it is that we give to the customers, and we're just looking at profits. So we want to look at our profits over time, right? And it gives us a description of what we are doing as a company, basically. And so it describes what has happened with our profits or what has happened with our sales over a given period of time. That's descriptive analytics. Now, there's another type of analytics, it's called diagnostic analytics. If you work as a system administrator, whether you're working in IT as a system administrator, you're working in engineering, you're working in healthcare even, right? Some catastrophic events do happen. So I'll go through this definition first and then I'll explain. So this emphasizes the rationale behind an occurrence. It incorporates a broader range of data inputs and a degree of hypothesizing. Basically, now I will use a less morbid example like in healthcare. Let's use something like in power and electricity. Now we know that if, let's say, the voltage or the throughput or whatever measures in our electrical system have reached a baseline or they've reached a threshold, this input, this input, this other input, this other input, it causes the national grid to fail. Now that's diagnostic analytics. Basically, what we are looking for is what is causing this thing to happen every time. In IT, we'll look at it as what's causing our server to crash, right? So we have monitoring analytics, we have reporting analytics, all these things, they come in the logs. So in the event logs, it tells you that your CPU was at 99% usage and your RAM was also at 88% usage. And then network was at 100% usage. And that's what caused a catastrophic failure of the system. That's an example of diagnostic analytics. So basically, you're looking at all of the trends that led up to an occurrence. And usually, most times, most people want to use diagnostic analytics to figure out what is the cause of a failure. Is there any other example that I can get from this fine group, this very intelligent group that I have here? I'm shy as well, so if you want me to continue, I can continue. But I mean, if there's
No,
anybody,
we are not going to continue. We need to remove the shyness from the group. So who's going to talk now? An example of a diagnostic approach to data that's trying to infer something from an event, basically, right?
yeah, and it can be healthcare. So an example in healthcare, temperature of a patient, and then you
Exactly.
stack it with his blood pressure
Maybe blood pressure.
and
Then,
pulse rate.
yep.
Yeah, so you can now determine if this person is going to have what? Maybe they're going to have a fever. Let me not be too catastrophic. There are other
Yeah.
things that you can predict going on with somebody from their heart rate and their temperature.
Okay. No, I think those are great examples. Let's keep it going then.
All right, great. So another type of analysis based on the goal is predictive analytics. And again, I don't want to kill this Netflix example, but here's one thing that predictive analysis is. It's basically a recommendation engine, for instance. Now, Netflix, they want to keep you as a customer, but they also want to keep you engaged. They want you to come back every night after you finish work. They want you to come and watch Netflix instead of watching YouTube or reading a book, for instance. Now, what they will do is they'll predict and they would use their recommendation engine to predict what you are likely interested in based on the things that you've watched and other people like you that have watched things in the past and are still watching things. So basically, they would look at your history of things. You've watched action movies, you've watched romantic comedies, you've watched comedies, you've watched documentaries. These are the type of documentaries you like. There are keywords attached to those documentaries. Now they analyze all of that data and then they look at somebody who is similar to you in that pattern and what they watch next. And now they can actively predict what you might be interested in. That's one example. Another example would be in fraud detection. So your bank, for instance, they have an algorithm, and this is based on your historical data, right? Your historical data of your transaction patterns. You buy shawarma, then after shawarma, you buy suya, and then you go home on Fridays. Now, if you go and buy shawarma and you buy suya, and then on another day, you go and buy something somewhere else, several kilometers away, they know that's not you because they've analyzed your behavior. So they can predict that this next transaction, based on how you behaved in the past and based on other examples of fraud. Now, for instance, somebody else has used another card for somebody else to do that transaction several miles away. They can almost predict with a 99.9% certainty that that's a fraudulent transaction. So that's an example of predictive analytics. And that's us using machine learning. But there are people that can actually also just predict. And an example is just a simple linear regression in sales. So we've been doing sales of XYZ over several months every year. And then every year we have a 10% boost. So you don't need an algorithm to tell you that next year, because yearly we've averaged around 10% increase, and next year our sales is going to be 10% more. So we can now plan for resourcing. Now we need more salespeople for our sales. We need more people on the field. We need more iPads for those people, that sort of thing. So it allows you to plan appropriately, predictive analytics. And that's an example, just being able to use all of the data that you have to try and determine an outcome or something that's going to happen in the near term, right? So the last type is prescriptive analytics, and this suggests a course of action. Now, you don't see this too many times, but where you see it is very effective. I see it a lot in resource planning. So you have a customer care center. That customer care center, they take calls, right? Sometimes you over-resource. So on days where the calls are slow, you have a full customer center, full client care center. That's like with, let's say, a bank. And on, let's say, a Wednesday evening, they are fully resourced. That's a lot. I mean, you're wasting money on resourcing because you're paying all of these people to come. But prescriptive now gives you a way out of that. So you look at all of your historical data and you say, well, every week of April between, let's say, 12th and such week, we don't have that many customers. So we don't really have to resource that many. So it gives you a course of action. What do we do? Now we engage only part-time staff on a need basis, right? So we don't need to have 12 people in our contact center. Let's have 6 people instead, because we know historically that this is what's here. So basically it just gives you a course of action for so resource planning is an example of prescriptive analytics. I'll try again. Is there anybody else that has another example where, and I don't know everything. So, I mean, there are probably people that are more experienced in some of these things than I am. So, yes, again, Dami, thank you.
Sorry, I just want to have just a quick question here.
Yes, sir.
Could you please explain more on the differences between that prescriptive analysis and predictive analysis?
Of course. So predictive analytics, it doesn't mean that there's going to be a following course of action. An example like we use is in the recommendation engine. It's not doing anything. It's just going to, the analytics is all of these customers, they are going to want to watch this next. So that will keep them engaged. With prescriptive, you are taking a course of action. So the analytics is telling you what to do next. It's not just telling you what's going to happen. It's giving you an insight into what you can do to reduce costs or create a new business solution or a new or innovation in your business. So like I use the case for prescriptive analytics is resource planning. Now, compared to a recommendation engine is just going to tell the company, hey, these are your customers. Your customers, these are what we think that you would like to watch next. And this is what we think will keep these customers here. But with prescriptive compared to predictive is we're now going to hire more people, or we're going to reduce the number of people that we resource for this job. So that's the basic difference. There's a course of action with prescriptive. You're going to do something. So let's say, even not in the case of resource planning, let's say it's even in sports. These days, we see that people use prescriptive analytics in sports. You're watching the game, you're seeing how the opposition is taking advantage of your defense, right? And then you've analyzed it over the course of 30 minutes of the game. Now you're going to look at the next 60 minutes and say, what can we change based on what we have seen in the first 30 minutes that is going to end up with us winning this game after 60 minutes? Does that make sense, Danny?
Yes, makes a lot of sense now. Thank you very much.
Awesome. Any other questions at this point? All right, we can go to the next slide. So now we understand what data is, we understand the purpose of data analytics, and we understand the different types of data analytics based on what we're trying to achieve. Now, what are the steps in the data analytics process? The number one step, we need to define the questions that we're trying to answer using the analytics that we have. And we need to identify the data that we'll need to answer those questions and where we will source all of that data from. So now let's look at the example of a company, for instance. Somebody started a company, they don't know anything about data analytics, and they're making sales. Let's say it's a merchandise office. They sell water bottles and bags, for instance, but they don't know too much. This person just knows how to make very fine water bottles and very fine bags. Now they are now looking for a data-centric approach to managing the business. They don't just want to be selling water bottles and bags, but they want to see how they can maximize the use of their data to improve their business outcomes, right? That's improving sales and reducing costs. So the first question they want to ask themselves is, they look at their sales data. So people are doing transactions. They come in, they use their card, or they do cash. They've already collected some type of data from there. So they know how many of their customers are using cash versus how many of their customers are using cards. Now, let's say they go further and they open an online store with all of the cookies that people gather and all of the information. Now they can also determine if they have more female customers than male customers, or they have more young customers than older customers, right? All of this data goes into answering the questions, where can we maximize business profits? So where can we cut costs, or where should we put our budget and our resources into? So as somebody who is practicing data analytics or a practitioner of data analytics, the first thing that you want to know is what questions you are trying to answer, the data that you need to answer those questions, and where that data will come from. Now, using that same example where they have a water bottle and a backpack store. Now they've started to gather data. They now know that the average age of their customers is between, let's say, maybe they even do a survey. They might not even need online. They are at the stores. After you buy or you make a purchase, they ask you your age, they ask you demographics very quickly, and they ask you very politely if you want to participate. So now they know that most of their customers are between the ages of 13 and let's say 25. And then most of their customers are women between 13 and 25. And they also know that there are people from this background and that background. They are now able to answer the question, where should we put our marketing budget on? Now, when we're creating a campaign or when we're making an ad, let's focus on these set of people because these are the people that buy our products the most. And if there's also, our products are actually targeted at these other people. So what else should we do? Now that we know that this is working for this demographic, what else can we do to acquire the new set of customers? So defining the questions that you want to answer with your data is number one. Knowing where to get that data from, and then identifying the data rather, and then knowing where that data is going to come from. That is the number one step in the data analytics process. Now, the second step is, now that you've identified where it will come from, you need to go and collect that data. And you need to determine a strategy to collect that data. So how are we collecting that data? Is it we're using cookies from our online website? Are we making customers complete surveys? Are we physically going to ask customers at the stores? Right? Those are examples of ways that you can collect data. But let's even leave that of business. Let's even say things that you can naturally measure. So like I used the example of the city. You put a sensor on the resources that you have. You put a sensor on all the vehicles, whether they're used for waste management or they're used for transit. So now you know the speed of the trains, you know the speed of the vehicles or the buses that are on the road. And then you also know how frequently your waste management fleet is collecting waste and dumping it, right? So those are other ways of collecting data. And it's also part of the steps in the analytics process because you do need the data for the next step, which is to analyze. Now, next step is to clean data for analysis. A lot of data is raw in nature. So you would find duplicates. You find sometimes the sensor didn't read, and that would be an example for like a fleet management. Let's say the sensor went down for several hours and wasn't reading, so you have no values. So those values, it didn't read anything. So you can't count that as useful data for your analysis. You have duplicate data. So let's say it read, but it malfunctioned, so it duplicated that data. An example is like your POS machine that is reading a transaction twice, or your ATM machine that's reading a transaction twice. That's not useful. I mean, it's useful data depending on the team, but depending on your usage. So if you're looking at sales, you're looking at the number of people that were engaged, that's duplicate data for your analysis. But if you're looking at failures, a duplicate data might be important to you. A null data too will be important to you. How many times did our sensors go down in a month, right? So depending on the use, you clean the data for analysis. So cleaning data means standardizing it, making new fields. So you have your sales field, but you have to also compute your profit. right? Part of the process of cleaning data is to create a new field for profit. So you multiply it by 20% for certain products, you multiply it by 10% for other products, you multiply by 1.5 for other products. That's just creating clean data that you can use for your analysis, right? Next step is to analyze the data, and this is the most important part of the data analytics process, is literally to analyze the data. Now you have all of this data, it's been cleaned, you've removed, let's say, the duplicates, you've removed the nulls, or you've included the nulls, and you've included the duplicates to try to figure out what failure has occurred or why the failures occurred or something. So now you analyze the data, and then you want to make useful insights from what you've gathered, right? That would be the step. This is where you run your data through, for instance, a machine learning model that will help you predict, in the case of like a recommendation engine or fraud detection, right? Or you just use the data to show your team where you should be putting more of your effort in. So for instance, let's say the city does a travel survey on the residents. How many people go through several routes? What are the routes people are going through more frequently? At what times are they using these routes? So that we can plan better roads and we can also plan better real estate. So we now open up these new spots to reduce traffic in the city. Those would be very great examples of analyzing data that you have. All right. So collecting the data, making use of that data, trying to figure out whether you're using a model or whether you're just using rough analysis. That would be this stage. And then interpret and share the results. So a data analyst has done his work here. He has done step 1, step 2, step 3, step 4. But it can't just sit down in his head that he knows that he has done all of this analysis to make the city better, to make the company better, to make his own life better, or make their own finances better. But they also need to interpret and share the results, right? So that's where visualization comes in. So you use several tools to visualize. You can use Power BI, you can use Tableau, you can use Excel. So basically, after you've analyzed it, you want to make it in a concise way for decision makers, the people who will make the decision with you. So you want to share it with them, and you want to share it in a way that it's easily digestible. And that's the word, digestible. So that they look at 3 things and they are able to come to a conclusion on what they want to do with this data, right? So that's interpret and share results. And that's the final part of the slide, I believe. Can we go to the next one, which should be questions? So this has been a shy group so far. Let's see if we have any questions coming through.
Yeah, no, fantastic, Lade. Thank you so much. So quickly, questions? Yes, okay, that's a thumbs up from Israel. Yeah, Dami.
I want to ask, so which of these visualization tools do you recommend that we focus on? So we have Excel, we have Power BI, we have Tableau. I mean, we know Tableau is part of Salesforce, right? And we learned, you know, we've started using it gradually. So which of them in your I mean, from your experience, which of them is industry will I say which of them is really being required, being in demand? I mean, that's being in demand mode in most industries. I'm upcoming business analyst. I'm trying to become, not yet, but I'm trying to become one. And I know that data analytics and data analysis is part of what I will have to learn. And in all the roles that I've been seeing, they always ask for business analysts that are very proficient in Power BI, in Tableau. They don't really talk about Excel most times, you know. So that's my question. Which one do you think we should focus on?
So that's a heavy question, and I say that because it puts some faith in me that I understand how the industry works. But I'll give you what my experiences. But there's also room for research. There are two leading visualization tools today. There would be Power BI by Microsoft and also Tableau. There is also Google Looker. Looker Studio is also an option. I have some experience with Looker Studio. That's by Google. And those three tools are the major ones. What you also need to figure out is, apart from the industries, if it's a specific company, what tools are they using in that company, if that's your target. But in general, industry-wide, Power BI is a great tool, and I know some of the knowledge that you get from Power BI is also transferable to Tableau. It's also transferable to Looker Studio and to all the other visualization tools. So I would say any focus on any of those three. If it's a heavily dominated industry with Microsoft, I know government is heavily dominated by Google, so maybe Looker Studio would be like the preference for someone who wants to work for government. Now, for someone who wants to work outside government in private industry, I think Power BI is more popular with like private sector companies. I'm not sure. I'm just saying, but I've also seen that Tableau is one of the leading visualization tools. So Tableau, Power BI, and Google Looker Studio would be what I'll say you should do research.
Thank you very much. I appreciate it, sir.
Yeah, thank you. I think Israel's hand is up. Please go ahead, sir.
Yes, thank you very much for the very awesome presentation.
Thank you.
Right. So yeah, so I see that most people or most conversations in Canada, especially, are biased towards technology or engineering, right? And so for those of us who are in healthcare, we're not considered relevant in quotes, right? As the case may be, and it's difficult, coming to this realization that you either have to transition from public health if you're coming from Nigeria, especially, into this data world, as it were, in Canada. So I'm also going to leverage Laolu's question. I know, sorry, Dami's question. Yeah, Laolu. I know you've answered it a bit, but what data visualization tool, right, is cross-cutting? So irrespective of whether you're an engineer, you're a data person, or you're a health person, right? I know Power BI tends towards that, but what would you recommend as an expert, right, in that field? Then going forward from here, amazing presentation. I would love if you go deeper. I know Chief Boyo can help with this, right? To have another session, right, on the practicability and operationalization of these data tools. We can pick one, for instance, maybe Power BI, if that's what you're comfortable with, man, so that we can also learn, even if it's the basics, and take it up from there. Once again, amazing presentation. Thank you, sir.
Thank you so much, Israel. So to answer your question about visualization tools, honestly, what I've seen in the industry that's the most popular is Power BI. Me personally, I don't have so much, I have almost zero experience with Power BI, but I've intermediate experience with Tableau, and I have beginner experience with Looker Studio. Right. And what I found is that all of visualization is transferable because, again, you only break it down into several things. You break it down into the dimensions, which is label of the data, and you break it down into the measures. And then once you have that, you can create pie charts, you can create table charts, you can create bar charts, you can create maps with all of this. What the key thing is to understand the storytelling, the concept of storytelling. So to answer your question again, Israel specifically, Power BI would be the number one tool that I would say, and then there's Tableau, and then Google Looker will be distant third.
Okay, thank you, sir.
Thank you. I think Onoja
Sorry, just before Noja, if I may add to respond to, was that Israel, right? So try to understand. So I put those three tools in the chart, right? So look at them from their providers, right? And you can easily, ask yourself. So Microsoft, I would say that, is there anybody under the face of the planet that doesn't know Microsoft? Right? Microsoft, in my opinion, was one of the first software powerhouses that brought in Windows, right? That, now we can see, as it were, right? And up until very recently, everybody tended to go with Microsoft as a product because it's always been user friendly, right? So that's number one. And then Tableau was not always owned by Salesforce. Salesforce acquired Tableau. Now, why do you think Salesforce acquired Tableau? Now, Salesforce is another software powerhouse that would not necessarily want to create a tool, a software, an app, whatever you want to call it. They would rather not want to reinvent the wheel, and that's why they would rather acquire already, good products that are doing well in the market. And they decided that they knew that Salesforce out of the box was not powerful enough for data analysis. And instead of, building a software from scratch, they decided to acquire one that was already doing well, which is Tableau, right? Now, Google, I personally don't know anything about Google Looker, apart from the fact that I just Googled it. So I honestly cannot speak to it. But Google is just another powerhouse, right? Now, to leverage on what Lade said, that at the end of the day, for you, Israel, it is the principles of data analysis. Or let me go back to the last slide, right? The principles of you understanding what to do with the data. So this slide, so just give me a sec. And I think that's the most important slide here. What is important for you is the ability to do what is on screen right now. Exactly. Where the tool comes in is the last two, and predominantly the last one, because that's where you are interpreting and you are sharing. And it's literally just sharing. If you don't do the work, Tableau is not doing anything for you. Power BI, though the way they've done Power BI now, I'm more conversant with Power BI. You bring your data into Power BI, and then you can now start doing some of the analysis, the slicing and the dicing. And Power BI is actually, they're so user-friendly to help you now bring it to life so that you can present it to somebody and say, oh, this is the final product of everything that you have done. But if you don't know how to do the top three and number four, then Power BI is not doing anything for you, because Power BI is just like a monitor to render the work that you have done. Now, again, to buttress what Lade said, whether you use Power BI or Tableau, if you can learn one, and in my personal opinion, I think learning Power BI would be easiest. And I think it's the most popular. And I think it's the most popular just because Microsoft has been around for a very long time. Even from when I was way back in school, everybody knew Microsoft. So I think Microsoft is still leveraging. And even when you find JDs, so let's go back and ask the question, the elephant in the room. Even when JDs are saying that you need to have, data analytics, proficiency, expertise, and all of that, more often than not, they will say such as, or e.g., Power BI, Tableau, Excel, SQL. They're not just, if they put one, it just means that that's the tool they are using. But I can tell you that if you can learn one and at least have an understanding of one, then you can transfer that skill into any other one that the organization you're working for might be using. Thank you. And
very great points. Thank you, sir. Thank you, sir. Julie, please go ahead. Oh, I'm sorry. There was Onoja before Julie. Sorry, so sorry.
Oh yeah, that's true. Onoja, James. Right.
All right. Thank you very much. Amazing presentation. I actually wanted to, the answer you gave to Israel actually covered what I wanted to ask. So you've done justice to my question. Then in addition, I also wanted to ask, as a beginner in data analytics, what are the basics that an individual who is just stepping into data analytics, what are they supposed to equip themselves with?
Okay, so that's why this course was, or this session, we created this session, is to open your mind
Yeah.
also and stimulate you into the possibilities of it. Now, you've asked the perfect question. This is what we wanted you to ask, is how do you get into it? So data analytics, you start from understanding the entire concept, which is what we've given to you here, right? Now, you now actually also have to go and look for other materials that would, so let's say Coursera, let's say, I mean, you don't even have to spend money on it. You can do a YouTube course. There's Data Camp.
Okay.
Yeah, there's Code Camp as well. So some of these resources online, they get you from the beginning stage, which is understanding all of these things that we've just discussed, right? So that you are not lost when they start their own discussion. And then you're more prepared when you go into those courses, because you understand the analytic steps, you understand what data is, you understand the different types of data, you understand different types of data analytics. Now, you might get in a more comprehensive course like programming with Python and programming with R, understanding SQL, right? So those will be things that you also need to put into view. It's like getting the tools down, understanding the tools, and using those enterprise software that companies would require. So understanding Python, understanding SQL, understanding R programming. R programming is not as common anymore, but a lot of data analysts and data scientists used to use it. Some still do, and some companies still require it. And then the visualization tools like we've discussed, like Power BI, Tableau, using Excel sheets, because a lot of data is structural, and then you need to manipulate structural data. So understanding tabular data, right? So this is a good place to start, but your curiosity should now carry you on into finding other resources online. So that's just my advice there.
All right. Thank you very much.
Thank you very much,
No
Lade.
worries.
Julie,
I think Lade almost answered me. I wanted to just pretty much clarify. I attempted data some years back, but I ended up in data science, and straight away we went to Python, which was a bit of a headache for me. So I just needed to clarify on those two courses, data science and data analytics, if they really differ, or they literally come down to the same thing, processing data.
Julie, you've asked a very, I mean, that question is what I asked myself when I started as well, is what are these tools that I need to get into it? What are the ones that I want to avoid because they are not my strong point, or they are not my strong suite, right? So for data analytics, like you said, I mean, Python is not a big part of it. Python should be more in the area of extracting the data, cleaning the data, or just transforming the data, right? Depending on the organization. So that's another problem. It's how do you fit in an organization where they don't have like a resident data engineer? So now as a data analyst, you have to go and source for the data yourself. And that means learning some of those tools, the other tools like Python, learning tools like Microsoft Data SDT, or learning JavaScript. So those will be other tools that you require to get data from the source to where you, as a user, you want to make some analytics on it, right? Now, if you're working with a large size organization, we would assume that they have a data engineer, so you don't have to worry about the Python part of it. You don't have to worry about the data acquisition part of it. That's their job. It's their job to get that data to you in a location that is useful for you. But some tools that would definitely, like you might not know Python and you might not know the scripting, but a tool that would be definitely necessary for you, Julie, would be SQL. Because now the engineers will drop that tool, they will drop all of the data for you, and now it's your job to extract it and to present it. So SQL will be a very useful tool for you.
All right, thank you.
Yeah, you're welcome. Thank you very much.
Thank you.
Dami?
So thank you again for the presentation. Thank you again, Mr. Michael. So I've been listening to the discussion, and it sounds to me that if we want to learn anything about data analysis, we might need to learn Power BI, we learn what's it called? We learn Tableau and all of that things. But again, my question is that, do data analysts code? Because I know that Python has to do with a lot of coding. SQL, not necessarily. SQL is more of a scripting language, and we used to extract data. So, but Python has coding. And as a data analyst, I'm not sure there's anything that pertains to coding there. And even business analysts too, they don't really code. So now that you're saying that we might need to go learn Python, does it mean I have to go learn coding? I'm confused.
Okay, let me jump in quickly, and let me not say that you need Python. You don't need Python. It depends on the organization. So for a smaller organization, what I've seen is that they put a lot of work on the data analysts to go and look for that data, source the data themselves, transform that data, and then present it. So if you're working for like a small SME company, and let's say you have a contract role with them, and let's say it's a bakery, they might not have a data engineer that would help them take their data from where it should be to you that would analyze and interpret and check, right? So I'm just saying it's a useful thing to know. And these days, with these large language models like the ChatGPTs and the likes, Copilot and the likes, you might get a lot more resources with the coding part of it. You can write a simple prompt these days to GPT and say, can you write a Python script that does number 1, number 2, number 3, number 4? And that number 1, number 2, will really connect to an SQL database, extract such and such data, put it in a staging area, do this transformation, and then load it somewhere, right? So I'm not saying you need to have the skills, but it's a useful thing to have, especially if you're looking at employability. I hope that answers the question.
Okay, thank you very much. You ease my fear, so I can use ChatGPT to speak into the Thank you very much.
Basically.
All right,
Yeah.
thank you so much.
All
Yeah,
right.
no worries.
No, that was a fantastic response. Thank you so much. What I want
Thank you,
to
sir.
quickly do here is to thank everybody for joining today.